Hello, everyone. Thanks so much for coming today. It's really awesome to see everyone here, and thank you, Daniel and Manny, of course, for having me. So, sure.
Yeah, it goes on YouTube, so all the recordings.
Hello. You can probably hear me better now, or at least the camera can. Okay, my name is Brad Miro. I am a senior developer advocate at Google Cloud, part of an organization known as Developer Relations, or DevRel for short. What we do is we are the voice of the community, if you will. We are frequently meeting with folks like yourself, learning about how you're using some of the products that we focus on. So in particular, I do Apache Spark and Lakehouse workloads on GCP. So that includes products such as Dataproc and BigQuery, Dataplex, BigLake. A lot of these products I'll briefly talk about today. This isn't a GCP focused talk, but I may have sprinkled a couple things in here and there. So today, what I will be telling you about is building an open lakehouse powered by Apache Spark and Apache Iceberg. Two projects that you may have heard of. And if you haven't, you certainly will by the end of the talk. Okay, so here's briefly what we're going to cover in the about 20 minutes or so that I have with you here. So we're going to start off by talking about what is a lakehouse, what is Apache Spark, very quickly, because I'm sure most of you know what it is, open table formats, Apache Iceberg, Spark and Iceberg, and the love that the two share together, and then the future of open table formats. And if some of this seems a little confusing, bear with me, and we'll walk through each, and hopefully it clears it up as we go through. Okay, so let's start by talking about lakehouses, and specifically what is an open lakehouse. Now, traditionally, and I'm sure many of you have dealt with these issues before, a lot of organizations have data all over the place in not necessarily any sort of organized way. You might have some data in an on-premise data stack. You might have some in a blob storage in one cloud provider, some in the blob storage of another cloud provider. Not necessarily any consistency throughout. There's just data throughout the organization. And typically, the larger the organization, the more data silos there might be. But by silo, we mean data that doesn't necessarily have any sort of link between them or any sort of central management of all the data. Then we also have the traditional data warehouse, OLAP databases, where you're doing a lot of your analytics workloads, things like BigQuery, Redshift, things like that, where you are running those workloads in a relational database. Then we also have data lakes, which typically feature those blob stores that I was talking about. You can store any sort of data there, structured, unstructured, semi-structured, multimodal, just basically a place to dump your data. Now, the lakehouse is the best of all of these worlds and gives you the ability to essentially sync all of these together and get the benefits of the analytics and the relational database stuff that you get from a data warehouse, while also being able to just maintain all of your data in your data lake, all in one centrally managed place. So just basically think of it as the organizational architecture for all of your data. So what actually goes into an open lakehouse? Well, these are 5 of the components that I think are most important. So we start off with storage. So in particular, when you're going to build an open lakehouse foundation, you're going to think about these open table formats. So you'll use things such as Iceberg and Hoodie, which again, we're going to talk more about in just a little bit. And then you also have a data processing layer. You might use Apache Spark for that, perhaps. But you can also use, there's a slew of tools out there. You have Apache Beam. You have even just Python Pandas. There's so many different tools for doing batch and streaming processing. You, of course, can use SQL. You can use open source engines. There are a lot of ways to do these in, without using open source tools, of course. But here, Apache Spark is open source. We're talking about open lakehouse foundations. So here I'm just sort of highlighting some of the more open features. So with storage and data processing, we also have orchestration for workflow management. So this, you might use a tool such as Apache Airflow for actually orchestrating your data engineering or machine learning jobs. And then, of course, we have analytics and AI ML. What is all the point of all of this data if we're not going to actually use it to extract value? So we build the foundational layer, and then we extract insights. We'll build models. We'll also build business intelligence dashboards using a variety of tools out there. And then sort of underpinning all of this, I think, is governance. So this is actually how we make sure that the data is safe, secure, accessible. And so that includes features such as data discovery, data cataloging, access control, and metadata management. So I could do well over an hour talking about all of this, but for the most part, we're really just going to talk about the storage layer and the data processing layer. But if anyone has questions, I'm happy to talk more about this after the session. Okay, so we're at the Apache Spark Meetup. Let's briefly just give a recap of what Apache Spark is. So Apache Spark, it's a big data processing framework, totally open source. It was initially released in 2014 to the public, and the most recent version is 4.0, or the latest major version, I should say, is 4.0, which has been available since May. Had a lot of really awesome features with it. One of them, namely, being ML support for Spark Connect, which I think has been really cool, and just making machine learning using Apache Spark much more accessible. The taken directly from the Apache Spark website is that it is an open source unified analytics engine for large scale data processing. It is currently the 4th most starred project across all Apache projects. So I always love showing this. And actually, it's very, very close to Airflow. It has about 41.8 thousand versus 41.9 thousand. So that might shortly jump up to 3, but it has a bit of a ways to go before the data viz library is up there. So very, very popular, been around forever. It's more or less the industry standard at this point, which again, I'm sure many of you here know. In-memory distributed data processing, rich ecosystem with things such as like MLlib for machine learning, Spark SQL, which allows you to do the computations using SQL-like syntax, and then GraphX for doing graph processing. It's available in 4 languages, Python being the most popular, and then Java, Scala, and R. Spark itself being written on top of the JVM. It initially was, a lot of heavy Scala usage, but I've definitely seen that shift more towards Python and PySpark over the last several years. It's also the one that I primarily use. Another really nice feature about Spark is that it abstracts the parallelization away from you. So what you have here is essentially, back in the day when you were building these distributed systems, you had to do a lot of the manual configuration yourself if you had multiple different machines, and you had to sync them up and also distribute workloads across all of them. Spark essentially does that for you. You just submit your code, and in the back end, it figures out where the data workload should be run, to heavily generalize here. And again, the number 4 most starred Apache project. This was taken yesterday. So maybe it's changed, but I'll assume it hasn't. Okay, so that's Spark. Let's talk about open table formats and what these things are. So just a very quick history about data management starting from 1970, well before I was born. We have the old school database management systems, which, as many of you know, they used to be fairly complex, they still are, and frequently are monoliths. So you'd essentially have one interface that would manage all your data, but also allow you to do analytics and processing on top of it. But they didn't really talk to each other very well. It was hard to import data in and export data out to different systems, let's say. So lots and lots of problems, even though we still have a lot of these being used in production workloads today. Now, jumping quite ahead a bit, one of the biggest, things to happen in the data space was the introduction of Apache Hadoop in 2006. And what this did was it separated the compute layer of your analytics workloads and your storage layers. And on top of that, the data that you could store in Hadoop was these more common file formats such as CSV, text files, and Avro files, back in 2006. So this was huge and really just unlocked a lot of different workloads and flexibility in being able to manage your data and do analytics workloads in a more efficient way. This also used a popular framework at the time called MapReduce, which was the ability to do processing across these different machines and being able to distribute workloads and then return the results that you needed. So then a much smaller time jump to 2008 was the introduction of Apache Hive, which was a tool that lets you do SQL syntax and SQL analytics directly on the data in Hadoop. And this used a directory-oriented table format. So essentially all of your files were broken down by keys in the file format itself. So for instance, you could have like a year, month, day syntax where the directory would be like year equals the year number, the day, month equals the month number, day equals the day number. And that was really awesome at the time because it provided a way to essentially do a search over the data without actually looking at the data. It was all baked into the directory paths, which at the time was a really big deal and definitely was a huge performance gain. And clearly there was a lot more than this, but this is just some of the things that I thought were important to highlight. In 2013, we had the introduction of columnar file formats, namely Parquet, which I'm sure most of you are familiar with, as well as ORC, and these enhanced query performance by virtue of having the columnar file format piece of it. Also, this bit.ly link here is a really awesome article that I read that sort of went into the history in much more detail. So I think we're sharing the slides later, but if anyone wants to take a picture, that's definitely a good read if you have like 15 minutes or so. Cool. Okay, so what were some of the pitfalls of all of that, especially the Hive and Parquet world? Now, Apache Hive, it's still very popular. It's still used in many production workflows, but it's certainly, a lot of the pitfalls did start to show themselves after about a decade of this thing being used in every major, corporation, especially all the big tech companies. Directory-oriented tables are actually limited, or at least at the time of, let's go back about 10 years, by a lot of service level concerns. So for instance, if you needed to search all of your data, something like S3 or even, GCP had limitations and how many files you could list in one API call. So if you had, let's say, a million different directories, you would have to do, several calls to actually get access to all of this data, as well as, that then introduces rate limiting concerns. So there were just things baked into some of these cloud providers that made just using Hive in the directory-oriented format much more difficult. Over partitioning can also occur, especially when you use something like year, month, and day. So that, of course, could lead to data skew and just all sorts of issues with actually doing analytics on the data. And then, Hive was frequently very reliant on using an external metastore, which is generally a separate separate compute that is running software that can tell you where all of your data is in the system. But if that goes down, that could theoretically take down your entire, all of your analytics jobs at the company, which, as you might understand, is very bad. So that brings us to Apache Iceberg. So what is this thing? Well, the solution to using the directory-oriented format was to actually use a log-oriented format. So essentially, any changes made to the table were appended to, generally speaking, were appended to a log. And with that, you had access to all of the changes that actually happened to the data, which also lets you do things such as time traveling to older snapshots. So, and I'll jump ahead a little bit, but what's really awesome about Iceberg is that it's, it's widely supported across all the different cloud vendors. It's another one of the industry standards. There are other table formats, and we'll sort of talk about those too, but Iceberg is definitely one of the most popular ones. Very widely supported, at GCP, it's definitely the one that we're, definitely heavily indexing on. Another important piece of Iceberg that was missing from Hive for a while was ACID transactions. And so what that meant, for those who aren't familiar, that essentially means that you can perform operations on the data without concerns of race conditions. And so ACID, essentially prevents that. As well as doing time travel to older snapshots of the data, you also have things such as if you were to change the schema, you don't have to actually rewrite the underlying data. So if, before this existed, let's say you wanted to add a column, you technically, in a lot of cases have to add, let's say, like a null value to former data, or like come up with a value for that. Here, you don't have to do that. Hidden partitioning without modifying the data files, so same deal. You can basically make changes to the data without rewriting all of it. And then, of course, what I think is one of the most important things is that because Iceberg is so popular, it has interoperability with a wide range of data processing frameworks, including Spark. So Spark and Iceberg Spark is, I would say it's the most popular open source big data framework out there today. And Iceberg is definitely one of the most popular, but there are two others. So they are a match made, a very nice match, if you will. Spark has lots of open source connectors that allow you to seamlessly read and write directly to and from Iceberg tables. Both of these are open source, so things like vendor lock-in are things you don't have to necessarily be concerned with. And then both are extremely active projects. Spark's been around for over a decade. Iceberg came out, I believe, in 2017, so it's definitely not new. And again, just continuing to grow, heavy adoption. All of the major cloud players have support for both of these. And just really cool. And I'd say, definitely two tools that any data engineer or data scientist should have in their toolbox. So where do we go from here? So if anyone's familiar with SpongeBob, you might know exactly what's going on here, but this is Squidward saying future. Anyway, so what is next? So there's currently 3 dominant open table formats. So there's Delta Lake, which was created by Databricks, another company y'all might be familiar with. There is Iceberg, who now Databricks, I recently learned, is one of the dominant players there. And then Hoodie, who I don't remember who created them. But the 3 of these are, I honestly see them all pretty equally popular. I've maybe seen the cloud players adopt Iceberg a little more heavily, but they're all, very popular. There are others. I don't see them pop up that much. It really is these 3 nowadays. In terms of also what's next, I've seen, especially Google, like they're building a lot of feature parity between building an open source lakehouse using Iceberg versus say something like BigQuery. BigQuery being our enterprise data warehouse that is full of awesome features. And we recently announced a feature that makes Iceberg tables essentially first-class citizens of BigQuery. And we're continuing to build out that feature parity over time. There's also the idea of making data more accessible. So right now for let's say something like Iceberg, there is a tremendous amount of support for Iceberg with all of these open source processing engines, but they do technically rely on their own integrations. So Spark has its own plugins for Iceberg, Presto has its own, Trino, Flink, they all have their own, custom code that's necessary to actually interact between the two. But what we're starting to see is the concept of REST catalogs come into play. So again, at Google, we have what's called the Iceberg REST catalog that lets you access that data simply using just a REST call. And because of that, you can then build that into even more data processing frameworks without needing to make those custom integrations and serializations and things like that. What we're also starting to see more of is unification layers. Now, the reason for this and what this means is, as I mentioned, we have Delta Lake, we have Iceberg, we have Hoodie. There's also just native data inside, like, again, BigQuery, just like BigQuery tables. There's also just the raw files that aren't necessarily managed by one of these open table formats. And what we're starting to see is we want to be able to access all of these without necessarily knowing or caring what's underneath them. So I've listed 3 different tools here. Apache Xtable being an open source tool, Google Big Lake being our being a Google product, and then Databricks Data Uniform coming out of Databricks. The idea behind all 3 of these is taking all of these tables and shipping them under a single API so that you don't necessarily care what the table format is underneath the hood. To the user, they're just able to access and view all of their different tables. Doesn't matter if it's Iceberg, Delta Lake, Hoodie, these products or these projects are able to just have everything be viewed as the same. Because most folks don't necessarily care what's happening underneath the hood. So I included a few links here. Just again, I work at Google Cloud. This is the stuff that I think is cool and that I use on a regular basis. So I included the link just like if you want to learn more about Spark, especially on Google. Here's a link here. Next up is how to create Iceberg tables inside of BigQuery, and then also getting started with the BigQuery Iceberg REST catalog, which has been a pretty sweet toy that I've been playing with, or product, I guess. And then just last but not least, just because again, we talked about lakehouses, I just want to sort of show you how some of this stuff fits together. Now this is again from the lens of Google Cloud, but this, all of the major cloud providers can do something similar with this with just different products. So when we're building out a lakehouse, you generally want to start with your data sources. So in our case, we have cloud storage, which is the same as S3, or I'm forgetting the Azure equivalent, but yeah, it's just your blob store. We also have managed Kafka, which is exactly what it sounds like. So you can have data coming out of there. You can stream that or have that managed by BigQuery. So in this case, we can use Big Lake tables for Apache Iceberg, which is managed Iceberg tables inside of BigQuery. You could also have external tables, which is essentially any other file format that Iceberg doesn't necessarily support. You can have managed within BigQuery and have the schema of the data auto-detected. We also have governance, like we mentioned. So in this case, we have things such as column level access control, automated data quality rules, which can check and make sure that as the data changes over time, it's still adhering to the quality that you expect of it, as well as data lineage. I know we have lineage, we have some folks here who work on lineage on a day-to-day, so we love that as well. We also, so we have the data coming in, we have the governance, we have the storage layer, and then we also have data insights and processing. So you can use Apache Spark. You can use something like, in our case, we use Gemini, which is our LLM that we are incorporating into all of our products. And you can do things such as data insights, where Gemini can look at the data that you have in the schema and offer suggestions. You could also do machine learning using Vertex AI, which is our MLOps tool for all things AI ML that you could ever possibly need. And then we have Looker for doing data visualization and building out dashboards. And again, I showed you Google products, but you can do this with any of the providers. This was just like the one-to-one mapping to sort of show you what a typical lakehouse might look like from our lens. And that's it. So thanks for tuning in. I hope you learned something. And are we doing Q&A now, or do you want to?
Questions now?
Sure. I'll also be around, so feel free to just come up to me. I like to think I'm pretty friendly. So.
Actually, can you take the position on why I don't need Iceberg?
Why you don't need Iceberg?
Yeah.
You don't want to, or you don't care. I mean, honestly, so some of the I know we're going to talk about this.
Yeah, there's a simple question at the panel, so.
Yeah, but you're going in the right direction. So we'll come back to that.
Cool.
AWS came up with something called S3 tables, which is like built-in support for Iceberg. Does Google Cloud also have something similar?
Yeah, so we have that big lake tables for Apache Iceberg, which is your data lives in cloud storage, but managed by BigQuery. It's essentially very similar. Yep.
Would you recommend, this seems like Spark and Iceberg are very nice, it's a nice match. What about some more real-time processing, like a Flink or a more CDC use case? Does Iceberg work as well in something with a high velocity change rate?
Yeah, it certainly does. And I think one of the cool things about Iceberg too is because it, as my understanding of it, because of the nature of it using the log, like the fact that it manages its metadata via logs, like append-only logs, you can, as the streaming data comes in, it's essentially writing that data to that log so that you have access to it in many cases almost in real time, depending on how the implementation is. But yes, Iceberg does work really, really well for streaming data.
And also Spark 4.1 is going to support almost like real-time queries. Yeah, I think sub 100 milliseconds.
Yeah, it's crazy.
Yeah, so relates to Spark.
Yeah.
Does Iceberg support the Excel format yet?
I don't think so. Not as far as I'm aware. Yeah, I'd have to double check, but no, I don't believe so.
Does it handle, like, say, millions of small files? Does it do the compaction, relatively reliable way?
Yes, it can handle those files. I still think you run into depending on your partitioning, you can run into issues there. I think there is some auto repartitioning of the data that happens with Iceberg, so that if it notices that you are running into like over partitioning in certain areas, it can rebalance. But generally speaking, it does handle those millions of files better than something like, let's say, Hive does, just because it's able to at least locate your data much more easily than some older formats may have.
Cool, thank you.
Thank you.